Okay, welcome Year 12s. In this video, I'm going to run through the core section of your trial exam. I'm not going to go through every question. I'm going to go through the ones that are listed just in the description. These are the questions that weren't answered super well, or questions where it would be a lot harder for me to just describe how to do it in writing. So I thought through a video would be a lot better. So if you want to skip ahead at any point to see a particular question, then feel free. So just with the data analysis, I've just got a few to run through, maybe 4 questions mainly that I want to look at, but just want to touch on the first couple of questions before I get to them. They weren't answered too badly, but there were, I guess, more people that got these wrong than I would expect. So just with this first one here, it asks you about the shape of the distribution. So remember, you can look at either of these two, the histogram or the box plot, when you're assessing the shape, because I think what some people might have done when they were looking at the box plot, they might have, I guess, just looked a little bit too far into it. If you have a look at the histogram, you can see that it's very clearly approximately symmetrical. It's not perfectly symmetrical, and that's expected with most distributions. But if you look at the one underneath, obviously the median's not exactly in the middle. And I mean, I haven't got a ruler here, but I can't see whether the whiskers are exactly the same lengths. But I think as well, some people might have got a bit sucked in by the outliers. When you're looking at the shape, you should just ignore the outliers at first and just have a look at what you've got in terms of the box plot. And then, of course, when you mention the shape, you'll also say that it has outliers. So if you have a look at the answers that we've got here, it's very obvious we do have outliers. So it means that A, B, and C couldn't possibly have been the answer, since all of them say no outliers. And so then all you had to work with was either positively skewed or approximately symmetric, and it was approximately symmetric. With number 2 as well, I wanted to mention, again, it wasn't that a heap of people got it wrong. It was just that those that did get it wrong, these are the questions you really want to be getting, because they're not meant to be, I guess, super difficult. So the number of babies, and notice it says number of and not percentage. So that's where the problem has come about with this question. Because if you have a look up here at the histogram that we're given, and if you have a look, it says between 3,000 and 3,500 grams. So that is this column in here. If I have a look at the approximate height of that, you'll see that it is about 37. But that means that we're working with 37% of the total number of babies, so the birth weights, I should say. So if we have a look at 37% of 200, there were 200 babies altogether. So 37% of the 200, and we get 74. So, and the question 2 was D. So as you can see, of course, they put this one on the list because they know that students are going to misread the histogram. And that's unfortunately what happened for a couple of you. I'm going to skip ahead to question 9. So this one wasn't answered super well, so I'm going to run through how to do it. If we have a look here, we are asked to get the slope of a least squares line. We don't have any data for that line, so all we have to work with is the mean of x, the mean of y. We've got standard deviation there as well, which we don't actually need, and we've got a, which is our y-intercept. So what you know about the least squares regression line is that you can get it on your calculator, or you can actually get it using one of 2 formulas. So here's one formula, and I'm writing this one first because that's the one we're actually going to use, but there's this formula as well. So the reason I think they've given you the SX and the SY is because we can't actually use this. It's a bit of a trap. They've given you this information, SY and SX, but they haven't given you R. We don't have R anywhere in this information here. So we can't actually use that to get the slope. What we can use though is this one, because they gave us A, which was 3.1. And then we've got 5.6 for the mean of Y minus B is what we're finding, and x was 5, mean of x was 5.5. So if you put that into your calculator and solve, you'll get a B value of 0.4545. It keeps going, but of course, when you round that, it'll just be 0.45. So the answer to question 9 was B. I'm going to move on now to question 11. Here it is here. So we've got some information about the variables. We're told it's nonlinear. We're also told that to linearize it, they've done a log 10 transformation. So it's actually a log y one in this case. And we're given the new equation as well. So this is the transformed equation. So we're using this equation that's given, the mean number of children per woman. So we want this, we're finding this, with an HDI of 95. So we're given this HDI value. We're going to substitute that into this rule, and we are trying to get a prediction. So we're just going to substitute in and find the children value. But you need to make sure you use log 10, which means you're going to have to use solve with your calculator here. So in your calculator, you'll write, or you'll do solve, and then you'll have log 10. Now, in terms of the variable, I'm just going to put C, because you don't need to put children, equals 1.06 minus the 0.00674, and the HDI is 95, so I'll put times 95. Then, of course, I put common C so that it will solve for C, and the value comes out as 2.628, so rounded closest to 2.6. So question 11 was C. Moving on to 12. This one here, there was a fair bit of reading involved in this question, but we're trying to find what could be true. So we're looking for things that aren't right in these statements so that we can eliminate them. So this first one here mentions a correlation coefficient, so that's our R value, between height and foot, and it's got the lengths in centimeters, so both numerical variables, but it says that the R is 1.24. Now that is impossible because R should be between -1 and +1. It should be less than or equal to 1. Which makes this one impossible. So that's not true. Correlation coefficient between height. Now when it's got in brackets here, it's telling us how it's been measured. Height here has not been measured in centimeters. It's been measured below average, average, or above. This is categorical data. Now with categorical data, you cannot get an R value. For R, correlation coefficient, we should have only numerical variables. So this one can't be true either. And if you have a look at the next one, low, normal, high, same problem. And this bit here, under 25, that is categorical data there. Height of students is the same age, centimeters, and money in dollars, so they're both numerical. And we've got R value of 0.22. Now that means that there's actually no correlation between the two. You usually get a random scatter of dots. That's possible, especially given if you look at those variables, you wouldn't really expect there to be a correlation between those two things if you're looking at heights of people that are actually the same age. And if you have a look at the last one there, like why would this one be incorrect? We've got an R value that is negative and then an R squared value that is negative. Now this here, an R squared that's negative is impossible because when you square any number, positive or negative, you should get a positive result. R squared should always be positive. So that's why that one is eliminated and D is your answer for 12. Now, last one in the data section was 16, which was a little bit of a nasty one. Having a look at it, there was just one little thing you needed to look closely at, and that was this bit. So it's obviously dealing with seasonal indices. As you can see, it's dealing as well with Wednesday. So just put a circle around that. And we're looking for the expected or the actual, could have said actual, labour cost on a Wednesday. So just as a reminder, the seasonal index is your actual value divided by your average. So that's a starting point for you, but some of you might have tried to do this with the average that you got and get something like in the 12,000s, and your answer's obviously not on the list there. So you might have got a bit stuck. So what you need to consider is that when we're looking at the actual over the average, that should be the daily, and that should be daily as well, since we're only looking at Wednesday. And this here was a weekly labor cost. So if we want to get a daily labor cost, we need to divide by how many days this cafe is actually open. So see how they're closed on the Tuesday. That means that we're actually going to divide this number here, the 9786, we'll divide that by 6 so that we can see per day on average the labor cost is $1,631. That means that what we can do is 1.24 is our seasonal index. Our actual daily is what we're trying to find, actual. And the average daily was 1631. So in other words, the actual is going to be 24% higher than this 1631. So to get your actual, you can just do this, which some of you would have used, 1.24 times 1631. That's re-seasonalizing just there. Or you could have used this and solved for actual. When you do that, 2022 point doesn't matter, because when you round it, you'll get this one, so closest to E. So that's it for the data section. So only really those 4 questions that were a big concern. And moving on, there'll be a few that I look at in the financial part. So in financial, the first question I wanted to mention was number 19. So here you're given your occurrence relation. You have to match it to what this could be modeling. So with this one here, I first looked to eliminate anything. So I'll just zoom in a little bit. What I notice is we've got our original value. We've got it increasing. So it's because it's being multiplied by a number greater than 1. It's increasing first, and then 2,000 is being taken away. So that may eliminate some things for you. So perpetuity, this could be a perpetuity. I'd need to check 100%. So I'll just leave that one for a moment. Could be. Annuity, it could be as well, because that would be increasing with the interest and then taking some money out of it. Annuity investment with additional payments of $2,000 per quarter. Now, it's not that one, because an annuity investment where you're making additional payments should have a plus here. And of course, it doesn't. An item depreciating at a flat rate. Now, this is very clearly not depreciation. First of all, it's not flat rate depreciation, because that doesn't look like this at all. That's just when you're subtracting a number. You don't multiply it and then subtract it. And secondly, if it was depreciating, this number here should be less than 1 to make the number get smaller. Compound interest investment, earning interest at a rate of 1.3. Well, that could be true, except that we've got this minus 2,000. So it's not just an investment, because something's going on with this $2,000. So we'll take out D and E and C as well, sorry. So we're really just deciding, is this a perpetuity or is this an annuity? And one of the easiest ways that you can decide between these two is just to pop this into your calculator and generate the terms for just a couple of the, well, you only really need 2, because if you see that the value is staying at 125,000, it's a perpetuity. So the balance is not changing. But if it does change, it's an annuity. So if we just quickly go to the calculator now, and put in our original value of 125,000. 1.013 was the R value, so times that by the answer that we've got here, and then minus 2,000. And then just generate a couple of terms, and you can see that the value of the balance of the investment is decreasing. So it is not a perpetuity. Oops, wrong one. There we go. So 19 is B. Now, just skipping ahead now to the last few questions in the financial part. So 21 to 24 is what I'm going to go through. With question 21, this can be done with zero calculations. I'll show you how it can be done with calculations as well. But what we've got is a part of an amortization table. You can see that it's a reducing balance loan. Well, you're told it's a reducing balance loan anyway, but you can also see that the balance of the loan is decreasing. So that's another giveaway. The other thing that we should look at is the interest, because under here we're told that the interest rate increases. So after one of these payments, we're not told, we have to find which one. After one of these payments, the interest rate has gone up. So there's a change to the rate that's being applied. And we want to know, when did this happen? So what was the first repayment made when after it went up? So all I do with this one, and you can answer it very quickly, is have a look at what's happening with the interest. It's at 349, then 343, so it's coming down. That's expected. The interest should be coming down because the balance is coming down. But then if you have a look right here, there's a change. So from 343 to 403, the interest has gone up. Now this should not happen if you are paying off that loan, if that balance is coming off of that loan. So what this means is, and in this payment, in number 17, which is the answer, which is C, that is when the first payment made at the highest rate. Now you can do it with calculations, but it would take you longer. As you can see here, I quickly just looking at the values, I could see that it was this one. And after that, the interest starts going down again. You can do it by looking at the actual interest, so actually finding it. So if I have a look here, the first time I can work out the interest is, I'll just take off that for a second. So I know that this amount of interest was paid for that balance just there, because that was the previous balance. So I can do 343 out of 34299.5 as a percentage, so times that by 100, and you get 1%, or it's 1 point about 1%. And then if I do that same thing, but not with those two, now with the next pair. So this interest now would have been charged on this balance. Let's have a look at what that is as a percentage. Whoops. 403.71 out of, let's go down a bit, 33642.5 times 100, and it comes out as 1.2%. So that just proves that it is higher, but like I said, you can do it just by looking at the pattern and that odd one out, which is right there. 22 now. We're asked for total interest paid. Now this information is going to be used for 23 as well. So I'm going to use the financial solver here for both of these questions. So we're asked about the total interest that Armand would have paid after 4 months. So if we look here, it's monthly payments. So in other words, after 4 payments. So what you want to do is look at how much have they paid back, or has he paid? He has paid 4 payments and it's $500. So $2,000 he's paid back. So if there was no interest at all, the expected balance would be what he borrowed, so $12,000 minus what he's paid back. So that's $10,000. You'd expect without interest, he's just paid back the $2,000 from the $12,000 he owed, and so $10,000 would be left. But we know that that's not the case with one of these loans, because he was charged 6.12% per annum of interest. So what we'll do now is look at what is the balance. So what is the actual amount that he owes? This is what we expect, the 10,000. But if we go to our solver, what is it actually? So 4 payments and it was 6.12%. PV was positive 12,000, that's what was borrowed. Payment was negative because it's going to the bank 500, and I'll just skip down here for a sec because it's 12, so monthly. And then we go to FV, so 10,231. Just close that because I don't need it. And oops, so 10,231. And it's got 0.327 or something like that, but it doesn't matter here because all we want to know, what's the difference here when rounded to the nearest dollar, since our answers are rounded. So without interest, 10,000 is expected. With interest, 10,231. So the difference between that is $231. And so the answer is A. Now moving on to number 23. It's using the same information. So what I'm going to do is, because I've got it in my solver already, it's helpful, I'm going to use that. So this question here requires you to use your solver a fair bit. You have to change things, you have to move things around a little bit, I guess. So first of all, after 8 repayments, he's going to decide to increase the value of his monthly repayments. So the first thing we want to do is work out when n is 8, what is the future value. So we want to know how much does he owe after those 8 payments. So I'm just going to scroll up here to change that to 8 and then have a look at what he owes. So 8,426. Etc. Okay, so he's going to then make these monthly repayments of $850, and then we're looking at one final repayment after that. So we don't know at this point how many payments of this $850 it's going to take before it gets to that final one. So that's the next thing I'm going to try and find. So how many payments does he actually need? So I want to find n. So what I'll do now is, since this is what he's owing after 8, I want to really sort of start again with this loan so I can see how many are remaining. So I'm going to use this FV here as PV. So it's the starting point of this last part of the loan. So what I'll do is press Control and then C to copy that value, and I'll move that up here and press Control V. Now, the thing is, at the moment, that is negative, and I don't want that to be negative. I need that to be positive since it's a loan and it's the start of the loan. So to change it, I just times it by -1 and press Tab, and that will change the sign. Now, the payments changed as well. That's got to be -850. And FV also has to change. He's going to pay it off, making these $850 payments. So let's go up to N now and press Enter. And as we can see, it's going to take 10 full payments and then a little bit more of a payment. Hence why we've got the 0.1985, etc. So what I'll do now is, going into this final payment, which is just after the 10th. So let's change this to 10. Let's have a look at how much is remaining when n is 10. So after those 10 payments, he's got 168.283 left. Okay, just go back here for a sec. It was 10 point ... So when n is 10, future value was 168.283 ... Now, the thing is, some students will get to this point and they'll circle A. Now, that's going to be incorrect, because when Armand actually owes this 168 going into that final payment, he will be charged interest on that $168. So the final step in getting this one is to add the interest onto $168. So all I do here, you really just need to do R times your value, R times Vn. So R's 1 plus your rate, so 6.12 divided by 12 over 100. So there it is there. And we'll times that by the 168.283 ... And it's only a tiny little bit of interest. It's enough to bring it up to 169.13. So the answer is B. So if you're having a look at your booklet and you know you got 168, you were almost there. You just need to remember that whenever there's that final payment, if they're actually using, going to pay that final payment off on in another month, so he's not adding it to the previous one. He's actually paying off that smaller one. It will be charged interest. Okay, finally, last one. Despite the fact it is the last one, I actually think this one is easier than the previous question. It's just a two-step solver question. I guess the hardest part about this one is it's so wordy. You've got this whole paragraph you have to read before you can get into it. So basically what's happening is Robin is accruing superannuation. So her employer is putting money aside. When she retires, she's going to put that money into an annuity, mentions down here, and then she's going to start taking money out of her superannuation. So the first thing that we don't know, that we need to know, is how much money does Robin have after 15 years? So your first step is to work that out. So we're told it's fortnightly, so 15 times 26. I is 2.5. We're also told that. PV, we're told as well, is what she's got in her super right now. Just make sure you put a negative on that because it is an investment. Negative for investments in the finance solver. Then we've got payment. That's what her employer is putting in. That also has to be negative. And then we've got future values, what we're finding, and PPY, CPY, since it's fortnightly, is 26. So when you do that, you should get 670,724 ... Okay, that's part one because we needed this bit. Part two, she's going to be investing this. So I'll just split this because now we're doing a second calculation. Now in the next part, we're actually going to get to our answer because the value of her payment is what we're trying to find. She's going to invest all of this money, so that's going to go up into PV. The thing is though, you need to make sure you put it in as a negative. So you can copy and paste like I did before and then just times it by -1 and press tab and that will put the negative in front for you. Rate has changed now to 3.6. 234 monthly payments is what she's going to have in there. I've left a bit of a gap there, but that's all right. Future value is 0 because we're told there'll be no money left. And just be careful because it changes to monthly here. So then you need to change this to 12. And then we're solving for payment. And it comes out as 3993.314. So that will be A. So then we have the final one. So hopefully you've gone through just, I guess, the questions that you've had trouble with. If there are additional ones that I haven't gone through in this video, please make sure you make that clear to me so that I can run through that with you. Thanks for listening.